Imagine this. You have two cars. One is a brutal supercar that guzzles fuel like a plane, and the other isn't as fast, but starts instantly and costs just a quarter per kilometer. Today, Google just released this second car in artificial intelligence form. It's called Gemini 3 Flash, and they're marketing it with a dangerous claim, frontier AI at a fraction of the cost. The question is this just clever marketing, or truly the model you'll use 80% of the time? In this video, I'll put it to the test with real challenges: a complete website, a game with unusual requirements, and a mini Windows in a single HTML file. And finally, I'll give you a simple rule to decide when Flash works better than Pro and when it will let you down. What Google claims versus what you actually need. Look, I'm not going to start with a table of numbers as if we were in a robot fight, because in real life, what makes you abandon a model isn't if it scored 2 points less. What kills you is this: if it takes too long, costs too much, or forces you to request everything twice. Gemini 3 Flash isn't here to say, I'm the smartest. It's here to say, I'm the fastest and the least painful to use. And that, for daily work, is a huge advantage, because there's an uncomfortable truth. When something is fast, you iterate more. When you iterate more, the final result improves. And when it costs less, you're not afraid to experiment. Now, pretty words aside, let's move to the first test. And the first test will be a complete website that doesn't fall apart. I'm going to ask for something that sounds simple, but usually breaks things. A complete website with clear structure, coherent styles, and an interactive component. Not just a landing page, I want a mini project. Home, service, about us, contact, appointment form, and when confirming, a model that says received and returns you to the home page. This is like ordering a pizza with exact toppings. It doesn't help me to get just something round. And this is where Flash starts to shine, because it writes as if in a hurry, but without going crazy. The typical result gives you 80% usable content in very little time, which is what you're seeing on screen. Perfect? No. Sometimes it changes a detail, puts 3 dots where you asked for 4, or leaves a section prepared instead of completely filled. But in practice, this means something very important. You don't start from scratch, you start from an almost there. And when a model gets you to almost there, the difference between having a project and not having one is your next prompt. Sure, this is web, but web is usually easy because it's template-based. Now let's move to what's unforgiving, a game with specific demands. And we're going to challenge it with a game that has demanding requirements. The idea here is simple. If the model truly understands your request, it can create rules, states, and controls without getting confused. I'll throw out a request like, I want a Tetris clone, but with 3D pieces, particles when completing lines, and an animated space background in a single HTML file. Plus, since many people have probably asked it to make Tetris, I'll request that the pieces have a sand texture or physics. This is like asking someone to make me a sandwich, but with homemade bread and fireworks when you take a bite. Normally, a model would make a basic Tetris, forget the particles, or deliver something that doesn't even work. But what's interesting is that Flash often does something that feels different. It actually fulfills the whim. It adds the animated background, visual effects, controls, and saves it in a file you can open and use right away. And you know what this changes? You're no longer testing a model, you're building with it. Because if it delivers a playable bass in 30 seconds, your next step is, okay, now add a counter, now adjust difficulty, now add sound. And that's when Flash becomes your iteration partner. However, this time, despite my very detailed first prompt, I got no results. I tried 2 more times telling it the figures weren't visible and everything was full of bugs, but it still couldn't fix it. So in this case, it failed the test for me. It managed to generate a website with a very predefined template, creating web pages almost always the same way. But the video game being something much more creative, it definitely couldn't handle. But there's still the most absurd test, the one that typically sounds like, yeah, right, this can't be done. Let's try a mini window where we want Windows 11 in HTML with functional apps. We're not looking for a perfect copy here. We're looking for something specific, organized complexity. We'll ask for a desktop, taskbar, start menu, windows that open and close, a simple word where you can type, bold text and save, a paint where you can draw and export, and if you're feeling ambitious, a basic browser. And when you see it appear, you get this strange feeling. This shouldn't be coming out so quickly, because the magic isn't that it's a real Windows. The magic is that it creates a convincing prototype. And a convincing prototype helps show an idea to a client, validate an interface, present a demo, or build a foundation. I mean, it's not the final building, it's just the scaffolding that appears. And this is where some ask, so is Flash better than Pro? The real answer is, it depends, but I'll explain why sometimes it seems so. I'm going to explain when Flash wins and when it doesn't. Flash is your first choice when 2 of these 3 things apply. You need speed, or if your task involves test, adjust, Flash gives you more attempts per minute. If you'll repeat the process often, like websites, prototypes, scripts, small tools, daily prompts, if you do it frequently, cost matters a lot. Or if you have a limited budget or want to experiment freely, if every token hurts your wallet, you might become conservative and use this model. It's also true that becoming conservative might cause you to miss opportunities. Now, when should you not use Flash? When you need maximum sustained reasoning over long periods, when you need extreme precision with no margin for error, or when a project is so critical that you prefer fewer iterations and more depth. That's where Pro comes in. Pro doesn't disappear, it becomes the surgeon, while Flash is the ER doctor. Valuable model isn't necessarily the smartest, but the one that helps you progress quickly. We live in a society where we want everything immediately, so the fastest model might be the most used, even if it doesn't always give the best. So answering the big question, yes, a cheaper and faster model can be better than Pro in practice, when your job depends on quick iteration and building working prototypes. And Gemini 3 Flash feels exactly like that. A model that not only knows things, but produces at human speed. If you're using it for prototypes, websites, scripts, and demos, start with Flash. If your task involves a tough question or delicate decision, try Flash first, and if unsure, upgrade to Pro. If you code daily, test it in Canva, and if you like it, switch to Studio or CLI to iterate faster. Now tell me in the comments, what would you build if a fast model was good enough and also cheap or free? And if you want me to compare the same task with the same prompt against Pro and other models, let me know and I'll set up a tournament style comparison. Let's also briefly talk about the Gemini 3 Flash benchmarks. And they're the part that's most easily misunderstood because it's not about winning for winning's sake, but learning what they tell you about model behavior under controlled conditions. In several benchmarks, Gemini 3 Pro appears neck and neck and even outperforms it in some specific tests. And that's very unusual. If you think of it as a smaller model, it should be equal or worse, but it makes sense. If you see it as a model optimized to respond better with lower latency and more efficient reasoning, for example, when you see comparisons where Flash matches performance in general reasoning tests or approaches multimodal tasks like understanding images, combining signals, following multi-example instructions, it suggests Google hasn't simply cut intelligence, but adjusted how and when the model thinks to avoid wasting tokens on simple tasks and reserve that processing power for complex ones. And that's why we also see that recurring message about better token efficiency. It's not just about what costs less per million, but sometimes needing fewer internal steps to reach a valid output. When they show price performance graphs or those maps where higher is better and right is cheaper, what matters isn't the exact number, but the gap it aims to fill. A point where cost drops significantly without performance falling proportionally. And that decoupling is exactly what changes the decision for average users. Because if Pro gives a marginal benefit, but Flash lets you try 4 times for the same price and responds faster, Flash might give better results per iteration. That said, here's the fine print that almost nobody mentions. Benchmarks don't accurately measure robustness in truly long tasks, consistency when pushed with contradictory requirements, or behavior when asked to maintain a plan across multiple steps. So while Flash may look impressive in programming benchmarks, tool usage, or certain reasoning tests, Pro still maintains an advantage when problems require maintaining context, reviewing solutions, and staying on track longer. In short, benchmarks are telling you a very specific story. Flash isn't claiming to be the absolute king. It's dominating the high performance per euro and second territory. And if that's your daily battlefield, prototyping, iterative coding, quick multimodal tasks, testing and fixing, those numbers aren't bragging. They're saying, this model is designed for all-day use without bleeding your wallet or your time.